Hey everyone, and welcome. Have you ever had one of those days where it feels like your own system is actively working against you? Just sluggish and slow? Well, if that sounds familiar, you are in exactly the right place. Today, we're cracking open the developer's playbook on system optimization. We're going to turn that sluggish code into a lean, mean, high-performance machine.
So let's just start with the big question, the one that kind of keeps us up at night. Is your application underperforming? Does it feel like you're just wrestling with your own code to get a halfway decent response time?
If you're nodding your head right now, then you're probably seeing some of these classic symptoms. We're talking about a poor user experience, the kind that makes people just click away. Maybe your infrastructure costs are just creeping up and up. Or maybe you just can't scale when you get a big spike in traffic. And here's the real kicker. You're starting to miss those super important API response time SLAs. And let's be real, these aren't just tech problems, are they? These are business problems.
And that's exactly why we need to talk about what I call the optimization imperative. This isn't just about making a few little tweaks here and there. No, this is a core part of our job as professional developers. It's a must-do.
So, when we say optimization, what are we really talking about? Well, here's the textbook definition. It's all about improving performance, efficiency, and scalability. But here's the part you really need to remember. We do all of this without changing the system's core functionality. That distinction is absolutely key.
And this is why it's so important, because it clears up a really common mix-up. Optimization is about making your app faster, not making it do more things. We're talking about refining the code we already have, not bolting on new features. It's like tuning a car's engine to get more horsepower, We're not trying to add a sunroof.
So why even bother with all this? Well, it really boils down to four main pillars. First, we optimize to make the user experience better, because let's face it, nobody likes a slow app. Second, we do it to slash those infrastructure costs by using less CPU and memory. Third, it's all about scalability, handling way more users on the same hardware. And finally, it's about meeting our SLAs and, keeping our promises.
Okay, so where do we even begin? We start right at the source, at the very foundation. We start by sharpening the code itself. This is where so many performance headaches are born. All right, here are four really powerful code-level tactics you can use. Number one, use efficient algorithms. That clunky, slow, nested loop you've got, it can probably be replaced with a lightning-fast hash lookup. 2. Stop creating objects you don't need. The classic example here is using a string builder inside a loop instead of creating new strings over and over again. 3. Stop using exceptions for your normal control flow. Seriously, they are incredibly expensive from a performance standpoint. And number 4, embrace async. Using async and await frees up your threads while they're just sitting around waiting for things like network calls to finish.
All right, so once our code is looking sharp, we have to look at how that code talks to the outside world. And trust me, streamlining your data and your APIs is often where you're going to find the biggest, most satisfying performance wins.
And why is that? It's because of this simple truth. Your biggest performance bottleneck is almost always I/O. It's all that time your application spends doing, nothing. It's just waiting for a database query, waiting for an API call to come back, waiting on the file system. That waiting time adds up.
Now, what's really interesting is that the strategies for fixing this stuff, for both databases and APIs, are surprisingly similar. When it comes to getting data, the rule is the same. Only ask for what you actually need. No more select X. For efficiency on the database side, you're using things like indexes, right? On the API side, you're using caching with something like Redis. The big idea here is to just cut down on the back and forth by batching your operations whenever you possibly can.
Okay, so our code is fast, our data access is super efficient, but there's one more resource that we have to manage like a hawk. It is time to win the memory game.
Yeah, good memory hygiene is just not optional. It all starts with properly getting rid of objects you're not using anymore. You can also use value types, like structs, for small bits of data that don't change, which takes some pressure off the garbage collector. And this one is huge. You have to actively hunt down and prevent memory leaks. That means unsubscribing from event handlers and clearing out collections when you're finished with them.
So, we've talked about the code, the data, and the memory, all in theory. But what does this actually look like in the real world? Let's see how it all comes together.
30%, just look at that number. What do you think that represents? It's not just some random number I pulled out of a hat. No, this is a real-world result.
This is a direct quote from a developer who did exactly what we've been talking about. They cut their API response time by a massive 30%. And how?
simply by swapping out a bunch of separate database calls with a single stored procedure, and then caching their static data. This is all the proof you need that these techniques get real, measurable results.
So, what's the big takeaway here? Well, here is your new optimization checklist. I want you to ask yourself these 4 questions about your own application. Are my algorithms really efficient? Am I only fetching what I need from the database? Am I caching and batching my API calls? And finally, am I managing my memory correctly?
And that just leaves one final question, and this one is for you. After going through this playbook, I want you to think about the system you're working on right now. What's the very first bottleneck you're going to go after?